Hello everyone, my name is Mohammad Tanveer Alam and I am a student of Alia University in second year BTech Department Civil Engineering. So today our topic is cement. So let's start. Here these all type of structure which is made with the help of cement. Cements are adhesive and cohesive material which are capable of bonding together particles of solid matter into a compact durable mass. Its primary function being to bind the fine and coarse aggregate particles together. Joseph Aspardine was the first to introduce Portland cement in 1824, found by heating a mixture of limestone and finely divided clay in a furnace to a temperature. Cement is composition of argillaceous and calcareous. Constituents of cement: lime 62 to 65%, silica 17 to 25%, alumina 3 to 8%, gypsum 3 to 4%, iron oxide 3 to 4%, magnesia 1 to 3%, sulfur 1 to 3%, alkali 0 to 1%. Function of different constituents of cement. First, lime imparts strength and soundness. Excess, it becomes difficult to combine with other compound. Free lime will be present in clinkers, which makes cement unsound, caused it to expand and disintegrate. Deficiency reduces strength of cement, cause it to set quickly. Second, silica imparts strength to cement. Excess increases strength of cement but increase setting time of cement. Third, alumina imparts quick setting property, reduces clinkering temperature if it is in excess, weakness the cement. Fifth, iron oxide imparts color, strength and hardness to cement. It induces reddish brown tint to the cement. Sixth, magnesia imparts strength and color to the cement. Excess makes cement unsound. Seventh, sulfur. It is also responsible for imparting soundness. No, soundness due to lime and magnesia can be measured directly, but no test is available to measure soundness due to sulfur. 8. Alkalis. Presence of alkalis cause efflorescence and staining of a structure. Alkalis react with water and white-gray spots are formed. Alkali accelerates setting of cement paste. Bogus compound. Various constituents combine in burning and form cement clinker. The compounds formed in the burning process have properties of second setting and hardening in presence of water. First, tricalcium aluminate. Second, tetracalcium aluminiferrite. Third, tricalcium silicate. Fourth, dicalcium silicate. First, tricalcium aluminate 4 to 14% by weight, formed within 24 hours of addition of water in cement, responsible for maximum amount of heat of hydration. It is responsible for initial set, higher heat of hydration and greater tendency to volume changes. Second, tetracalcium aluminiferrate 10 to 18 by weight. It is also formed within 24 hours of addition of water to cement. Amount of heat of hydration evolved during formation of this cement initially is comparatively more, which goes on decreasing with time. It is also responsible for flash set but generates less heat. Third, tricalcium silicate 45 to 85% by weight. It is supposed to the best cementing material and is well burnt cement, formed within a week of addition of water in cement, responsible for development of early strength of cement in initial stage, 7 days strength. Fourth, dicalcium silicate 15 to 35% by weight. It is formed very slowly after addition of water in cement and may require a year of so far its formation. It imparts resistance to chemical attack. It is responsible for progressive strength of cement in later stages. Note it, if early strength is required, increases C3S. Strength is required to be increased in later stage, increases C2S. Hydration of cement. The chemical reaction between cement and water is known as hydration of cement. Heat of hydration of Portland cement during 7 days is about 89 to 90 calorie per gram, and during 28 days is about 90 to 100 calorie per gram. Water about 23% of by weight of cement is required to carry out the complete hydration. About 15% of water is used up in filling voids of the cement particles. Hence, efficiency 38% of water is required to carry out complete hydration. Heat of hydration C3A greater than C3S, C3S greater than C4F, C4F greater than C2S. Rate of hydration C4F greater than C3S, C3A greater than C3S, C3S greater than C2S. Manufacturing of cement. Manufacturing of cement includes three basic operations. First, mixing. Second, burning. Third, grinding. Method of manufacturing of cement. Method. First, dry method. Second, wet method. Dry method is also known as new method, and wet process is also known as old method. Testing of cement. Testing of cement is carried out to analyze the presence of desirable properties in it. Testing of cement. Field test, laboratory test. Field test: first color test, physical property test, third strength test. Laboratory test: first fineness test, second standard consistency test, third setting time test, fourth soundness test, fifth strength test, sixth chemical composition test. Testing of cement. First, field test. First, color test. Cement should possess uniform gray color. Second, physical property test. Should feel smooth when rubbed in between fingers. Cement should sink in water and should not float over the surface. Sample should be free from presence of any lumps which are formed due to absorption of moisture. Third, strength test. Prepare a block of cement to be tested of size 25 into 25 into 200 cubic mm. Immerse in a water for 7 days. Now remove the mold and subject it to point load of 340 Newton by placing it over supports 150 mm apart. Sample should show no sign of failure under the application of this load. Lab test. First fineness test used to check proper grinding, which has direct impact on rate of hydration, rate of gain of strength and evolution of it. A sieve test. Takes 100 gram of cement and place it to IS sieve number 9 90 micron. Perform sieving for 15 minutes. Weight of residue should not exceed 10% of original weight for OPC. B. Air permeability test. Blenheim air permeability apparatus is used based on relationship between flow of air through cement bed and surface area of cement particles forming the bed. For OPC SSS, A should not be less than 2250 cm per gram. For rapid hardening cement, SSL should not be less than 3250 cm square per gram. Second, standard consistency test. Standard consistency should be before we know about soundness. Standard consistency permits penetration of vacuum plunger of size 10 mm dia and 50 mm height up to a depth 33 to 35 mm from top into the mold. We find the water content at which the cement consistency is produced. Take Take 500 gram of cement and add 23% of water by weight of cement in first trial. Lower the plunger gently up to surface of mold and release quickly. The moisture content at which this cement paste of a standard consistency is produced is termed as P. Third, setting time test. Carried out to know whether cement is deteriorated due to storage. Two times are associated with setting time. A. Initial setting time. B. Final setting time. A. Initial setting time. Time which is being measured from the instant water is added to cement up to the time cement starts losing its plasticity. Take 500 gram cement and gauge it with 0.85 p. Lower the square needle gently and release it quickly. Note time required by needle to penetrate 33 to 35 mm from top. This time is called initial setting time. For OPC, initial setting time is 30 minutes. B. Final setting time. Time which is being measured from the instant water is added to cement up to the time cement completely loses its plasticity and attains sufficient firmness. Take 500 gram cement and gauge it with 0.85 p. Lower the annular collar with needle gently and release it quickly. Final setting time is the time when annular collar fails to make an impression over the mold but needle does so. For OPC, final setting time is 10 hours. This is instrument. Fourth, soundness test. It is important that cement after setting does not show any appreciable change in volume, as it seriously affects the durability of the structure. Soundness of cement is due to lime, magnesia, and sulfur. A. Soundness due to lime. Gauss 100 gram cement with 0.78 p and fill the paste in mold. Cover top and bottom with glass plates and immerse entire assembly in water having temperature 27 to 32 degrees Celsius for 24 hours. Remove mold and note the displacement of a split with help of indicator arms. Then again we immerse entire assembly, increase temperature in 25 to 30 minutes up to boiling point and maintain it for next 3 hours. Note the displacement of a split with the help of indicator arms. The difference in reading in both the parts of test should not exceed 10 mm for OPC. Fourth, soundness test. Soundness due to lime and magnesia. This test is sensitive to both lime and magnesia. Prepare a mold of lean cement of size 25 into 25 into 25 to 50 mm. Place in an autoclave in which steam pressure is increased up to 21 kg per centimeter squared and is maintained for next 3 hours. The mold is removed. Percentage expansion of the mold is noted in a direction which should not exceed 0.8% for OPC. Strength test. Compressive strength test. Cement anywhere sand 1 proportion 3. 3 specimen cubes are prepared and cement, sand and water are taken. 185 gram 555 gram. P by 4 plus 3.4 P is equal to percentage of water required for a standard consistency. Mortar is filled inside 20.5 mm mold and immersed in water for 7 days curing period. Compressive strength of cement is tested in universal testing machine. For OPC, 33 grade strength at 28 days, 33 Newton per mm square at 7 days, 23 strength at 28 days. At 3 days, 50% strength at 28 days. 5. Strength test. Tensile strength test. Brickwork test. Fifth, strength test. Compressive strength test. Cement proportion anywhere sand is equal to 1 proportion 3. 3 specimen cubes are prepared and cement, sand and water are taken as 185 gram, 555 gram, P by 4 plus 3.4 into P is equal to percentage of water required for a standard consistency. Mortar is filled in size of 70.5 mm mold and immersed in water for 7 days curing period. Compressive strength of cement is tested in UTM. For OPC, 33 grade strength at 28 days is equal to 33 Newton per mm square. At 7 days is equal to 2 by 3. At 3 days, 50%. Tensile strength test. Brickwork test. Quicker indication of defects in cement is obtained than any other test. Cement proportion sand is taken in 1 proportion 3 by weight. Water to be used is calculated as P by 5 plus 2.5. Ordinary Portland cement should have a tensile strength of not less than 2 Newton per mm square after 3 days, 2.5 Newton per mm square after 7 days. Dimension of a standard brick weight. Here, instrument of brick weight. Tensile strength is equal to failing load by 25.4 into 25 into 4. 6. Chemical composition test. The ratio of alumina to iron oxide should not be less than 0.66. The ratio of lime to silica, alumina and iron oxide should not be greater than 1.02 and should not be less than 0.66. This ratio is termed as lime saturation factor. 7th, specific gravity test. It is done using lead chatelier flask. The flask is filled with either kerosene free of water or naphtha to a point on the steam between 0 and 1 milliliter mark. 64 gram of cement is introduced in it and a rise in volume is observed. A specific gravity of cement is 3.15. Bulk density of cement is 1440 kg per meter cube. Some important points. Total weight of magnesia should not be greater than 5%. Total loss on ignition when heated to 1000 degrees Celsius should not be greater than 4%. Total surface sulfur content should not be greater than 2.75%. Weight of insoluble residue should not be greater than 1.5%. Ordinary Portland cement. It is cementing material resembling a natural stone quarried from Portland in UK. It is classified as 33 grade, 43 grade and 53 grade. Ordinary Portland cement IS code 110262 has classified OPC grade wise form A to F as per 28 days compressive strength. A 33 grade 32.5 to 37.5, B 37.5 to 42.5, C 43 grade 42.5 to 47.5, D 47.5 to 52.5, E 53 grade 52.5 to 57.5, F 57.5 to 62.5. First, rapid hardening cement. Higher rate of development of strength must not be confused with quick setting cement. This higher rate of strength is attributed to higher fineness, which is obtained by finer grinding of cement at about 4,500 cm² per gram, produced by fine grinding of clinker, increasing proportion of C3S and reducing C2S. Strength of RSC at the age of 3 days is same as that of OPC at 7 days. After 90 days, strength of RSC and OPC is almost same. Used in prefabricated construction work, cold weathering concreting, where formwork is used for speedy construction, repair of a structure where load is applied in short period of time. Second, extra rapid hardening cement, produced with intergrinding rapid hardening cement clinkers with CaCl2, proportion of which should not be greater than 2% of weight of cement. This cement should not be mixed, transported, compacted and finished within 20 minutes of its formation. This cement has approx 20 to 25% higher strength than rapid hardening cement at the age of 1 year 2 days and 10 to 15% higher strength at the age of 7 days. After 90 days, strength is almost same as that of OPC. Application same as rapid hardening cement. The 3. Sulfate resisting cement. OPC is highly susceptible to attacks of sulfates. It's manufactured by reducing proportion of C3 and C4F such that C3 is not greater than 5% and 2C3A plus C4F should not be greater than 25%. Used in foundation work, sewage treatment work, marine structure and construction of pipes in marshy areas. Fourth, supersulfated cement, produced by intergrinding granulated blast furnace slag and 10 to 15% hard burnet gypsum and 5% cement clinkers. Application same as sulfate resisting cement. Portland slag cement, granulated blast furnace slag plus gypsum plus cement clinker, offer high resistance against attack of chlorides and sulfate. Higher water tightness property due to less permeability. Sixth, quick setting cement, produced by adding a small quantity of aluminum sulfate, fine grinding the cement clinkers and reducing proportion of gypsum, used in grouting operation and underwater concreting pavement construction. Quick setting cement has setting of initial setting time 5 minutes, final setting time is equal to 30 minutes. Seventh, low heat cement, produced by reducing proportion of C3A about 5% and increasing the proportion of C2S about 46%. This cement shows slow rate of development strength, used where bulk concreting is required. 8. IRST40 cement, a special type of cement used to manufacture sleepers for Indian Railways. It is prepared by finely grinding clinkers and increasing proportion of C3S to achieve high early strength. 9th, hydrophoic cement. It is produced by intergrinding cement clinkers with water repellent film forming substances like oleic acid and stearic acid. Water repellent layer protects cements from deterioration due to storage. 10. Portland Pozzolana cement, Pozzolana is essentially a siliceous and aluminous compound which itself does not possess any cementing property, but when finely grinded in presence of water, it reacts with CaOH2 formed during hydration process to form a compound which possesses cementing property. It has low heat evolution and it is used in places of mass concrete such as dams and in places of high temperature. Thank you.